All right. Thank you for joining. I am Greg Vanoni. I have a couple hats. I am a software engineering manager in site reliability engineering for PayPal. And then I have kind of two sort of moonlighting-ish jobs. One is as a president of a nonprofit called Opportunity Hack, and the other one is VP of software engineering at an EHR company called Silicon Mesa. Today, I'm going to be talking about everyone's probably favorite topic of all time that surfaces in many different ways, but it's a bug. No, it's a feature. No, it's actually a bug. Let's go into sort of how we got to this fun problem statement. This is actually based on a Medium blog post that I wrote. And also, if you want to follow along and check out these Prezi slides, you can go to tiny.cc/bugs_under-rugs, and you can also follow along. It should be available to you. So 2 years ago, we were a new team, and we were looking for some quick wins. We were trying to find something that would raise some eyebrows. And one of the things we looked at is the idea of dark data. So dark data exists probably all around you. You've got millions of computer systems collecting data that you're doing nothing with. In our case, Jira is the dark data target for us. It was also super clean because it has a lot of fixed fields and also has free text, but a lot of easy things you can do with Jira data without really having to manipulate it much at all. It was a known problem because we knew that there are bugs and there are features, and sometimes a bug gets classified as a feature. We also knew that we could estimate impact, which I'll go into, and we thought maybe there's some patentability here. But before I get into that, I want to talk about our team. So our team, like I said, is Site Reliability Engineering. Our team is called Actionable Insights, or AI, SRE AI for short. We were founded in April 2018. And really, our goal is to provide clear, accurate, relevant, and actual measurements of reliability and operations data. And when we're talking about bugs, I just want to sort of set the record straight, also sort of introduce some ambiguity here as well. But there's some caveats around what is a bug, what is a feature. Error messages that we all get, unknown error occurred or can't log in, right? Those are definitely probably bug related, whether it's in the code or in infrastructure or something in networking. Bugs, I think, are well known. Error messages are well known bugs. You've got something like the BMW iDrive, which if any of you have tried to use that, it is a difficult thing to navigate with. So I would consider that to be a bug. Some people would say that's a feature. And then hopefully more agreeable is the butterfly keyboard, where they would get stuck and you would be able to type. Hopefully you would agree that that is a bug and not a feature. Just wanted to set the record straight on that. And Jira, I'm going to talk about Jira a bunch in this presentation. We use Jira, and just to be clear, this is what Jira looks like. There, where that little star is at, it kind of indicates that the type of this ticket is a bug and the priority is a low priority. So that'll surface up a little bit later. And then if I zoom out a little bit, there's a bunch of different types of tickets you can submit in Jira. The other star is right next to the feature. And that can also be another thing that people submit into the Jira system is a feature. So I wanted to level set a little bit on what Jira is. We actually know that we resolve bugs faster. So if you listen to the keynote today, every data scientist loves to be able to prove value. In this case, we knew we could. So we resolve bugs faster than features. So we have a P1 bug and a P1 feature. The P1 bug is going to get resolved 68% faster than the P1 feature. And you can kind of see that breakdown on the right there. Now, we have SLOs, which are service level objectives for all priorities. So for example, you might have a P1 SLO where the P1 bug needs to get resolved in 5 days, P2, 20 days, something like that. If you have features, we don't really have a hard SLO on when those need to get resolved, right? That's part of a sprint planning process, and you're writing code, you're pushing out that to production. And so you're trying to hit a target date. So key point here is bugs, probably for you as well, get resolved faster than features. And we tend to work on bugs, especially high priority bugs, first before we work on features. And we also have dedicated teams that work on bugs. So I wanted to call that out. Now, let's talk a little bit more about this Jira dark data thing. So in Jira, we also have a priority, we have this bug feature improvement, and we have the idea of reassigning or assigning bugs to people, to development teams. And we were first brainstorming about this about 2 years ago. We wanted to figure out how to solve bugs, how to resolve bugs faster, mainly for customers so that we can make our customers happy. But also we knew that it was just good practice to fix bugs faster. So that's going to be the main focus of this talk. You'll see a little bit later, we actually did get a patent on this, spoiler alert, and it does include priority and a reassignment or assignment in there as well. But the priority problem is another interesting one. So if you have a P1 bug versus a P2 bug, hopefully that P1 bug gets solved before that P2 bug, or faster than that P2 bug, rather. And if you can make sure that that priority of that ticket is the accurate priority, we use a classification matrix that we created here at PayPal, where we actually can quantify a given bug, what priority it should be based on that. So if you haven't really looked into that in your organization, your company, definitely have some sort of classification matrix that allows for priorities to be set. Now, there's always some ambiguity there, and that's sort of where machine learning and AI can come in. It can actually automatically set the priority for you. It could automatically set that Jira ticket to be a bug. It could automatically assign that to the right team. And so over time, you resolve bugs much, much faster because you're using AI to help you there. So I'm going to zoom out and I'm going to go into the patent side of things. So this is our patent. It's been published a few months ago, can't remember exactly. These are all the technical details, which is great. I am able to share all details with you because of that. So there's our patent filing information at the top. Here's a couple screenshots from there. It talks about how we do assignee classification, how we find the right person to assign it to, how we classify the bug either as a bug or as a feature, how we find the priority of the bug. So all of this is there. I think the whole goal of this talk is to encourage you to do something similar with your data, right? This was new to us. Again, dark data, nobody's ever looked at this before. We had a hint that this could be patentable. Talking to our patent team definitely was. So I know that you can do the same in your organization and your company as well. Okay, so let's go into sort of how we did this, the how part of this. Our approach was to label bugs. That's every good AI solution for the most part has a labeling sort of part of it. And here we leveraged experts, but we also knew that when a bug was closed as a bug, we could use that as our ground truth as well. That sort of tells us that, okay, people believe that this thing is a bug because it was closed as a bug. So we went in, we labeled bugs, we build a model like everybody does. And then the interesting thing here is the survey. So you're probably thinking, what AI solution has a survey, which is why we'll go into that a little bit more in detail. But what I really want to show you here is we went from a bug to a feature is one thing that we cared about. When a feature went to a bug, it's another thing that we cared about. When a bug went to a feature, back to a bug, we also care about that. There's so many different combinations that we found by looking at this data. I mean, we're talking thousands of data points, literally. So that's sort of on the data side, how we did that. Now on the survey side, here's where I think things got really interesting. I was listening to some Freakonomics podcasts. So there's one that's called Big Returns from Thinking Small. And a survey is a really easy thing for us to do. Just send out a survey. And the whole goal was we actually wanted to collect data to see if it would change people's behavior just by sending out the survey. Again, it was a hypothesis. We wanted to test it. So A/B test, so we sent a survey out to a certain number of people, and then the control group did not get a survey. In the survey, let me zoom in a little bit. In the survey, we're asking all these radio buttons on the left there. Basically, why did this thing change from a bug to something else on this date? And we ask people, tell us why. We're trying to understand why. And most of those selections, for the most part, are just another way of saying this thing should have been a bug. You can see like system is working as intended. That one's a little bit sketchy. in terms of if that's a bug or not. But essentially, like, even if it's not a bug in my component, it's from another component, that's still going to be a bug. So we try to think about all the different things that people would tell us when we ask them why it was moved from a bug to, let's say, a feature or an improvement. And so this was automatically done. We scripted a tool to send out the survey. It was a natural A/B test. We could then do a student's t-test to actually show impact, which again is one of the things that you definitely want to do in any ML data science project. So we could automate it, and we knew that once we got the survey feedback, we could then use that to even label data even more with human expert labels. So that was another side benefit of doing that survey. Now, when I said that we emailed the survey, we did. We sent an email, and then we sent a second email. And I'm not sure if you respond to surveys you get in your email, but no one, I mean, most people did not, right? You can see here that Slack was really the main driver of getting people to fill out that survey. So we use Slack, we use email, and what you see here is I actually scripted a way to make it seem very personal, that I was sending people their own personalized Slack message. And after I did this, we got, as you can see here, we got a significant number of people to respond to the survey by me sending them a direct DM, if you will, Slack message. So a huge learning for us that Slack is going to be a lot more, it's going to push the tide in terms of getting people to fill out surveys, because surveys by themselves pretty boring. But if you have a personal touch to it, I think it really speaks a lot of volume. Now, our results, we'll get into some p-value fun in a bit, but our results just shown by the red line here. The red line are the people that were in the survey. The blue line, people that did not have the survey. You can see that after we surveyed 112 people, we saw their behavior change. So this is a chart of misclassification or mislabeling of something that should have been a bug, but was either a feature or an improvement. So you can see here, we were able to track this over a certain number of sprints, just so we could keep gathering data, keep seeing if people, after they filled out the survey, would still maintain that behavior. And this is true today. We still have every 4 or 5 sprints or so, we go and look at the data and see if things are still looking the same, and they definitely are. We've magically changed the behavior just by what we did here in this project. So p-values, everybody loves p-values. So we have 2 things that showed significant findings here. The people who received the survey changed their behavior. The people who then answered the survey, which is a different little cohort than the people who would receive the survey, also changed their behavior. Slightly less than the people who received it. There's a larger sample size in terms of the people who received the survey versus the people who actually answered the survey. So significant results, again, just by what is the easiest possible thing we could do? How do we test this thing and learn from it in sort of no effort at all? We spin up a survey, we send out emails, everything's scripted, and this probably took a sprint or so 2 weeks in our terms. Okay, so that's about our approach. We leverage some experts we have in site reliability engineering who really know a lot about if something is a bug or is a feature to label bugs. We actually created our internal tool. We call it Graffiti. It's meant for tagging, funny there, to label the data, to help us label the data a lot more easy. We actually could not find a sort of free solution that was easy for people to label just the CSV. Definitely, we're planning on open sourcing that to make it easier for people to label their own data. And you can see our F1 scores. So we started with 0.88. And then after we got our survey feedback, then we rebuilt our model, and then we got to 0.915. And then there's another iteration on this where we got to 0.94. So we used a random forest. It's the easiest possible thing for us. You'll see that in the patent as well. Super, super awesome way of being able to look at a ton of data, a ton of Jira data, and be an expert, label that data, reach out to people in the survey, and get that feedback. Okay, so that's on the why side and sort of how we did it. I do want to go now and just kind of summarize for you. I think, hopefully I didn't throw too much at you in this talk, but I think what you'll see in the summary is just revisiting some things. So the first thing is, I know it's in the title of the talk, but bugs can actually become machine learning features or AI features, and not just features in Jira in this case. So there's a ton of data that we had that was dark data that just existed without anyone looking at it from the data science lens. And there is numerous other examples I can talk about forever about what could we be doing with AI and ML that sort of is untouched. Key here is emails. When you're sending out surveys, or maybe even in general, I don't know, aren't answered as much as Slack messages. Definitely by sending that personalized Slack to people, and I think personalized had something to do with it, really drove those 100 or so people to respond to that survey. And that's when we reached sort of a level of confidence where once a certain number of people had responded to the survey, we knew that we were going to have statistically significant results. And Slack was the best tool for the job in this case. Very personal, we scripted it, we made it pretty easy to use. Kind of another key point here is we definitely did a lot of sample size calculations and things like that on the Jira data to understand what our margin of error would be, which I think was 2% or so. And then we have to layer that on top of the accuracy of the model. So there was a lot of pre-work that was done here, but I didn't even talk about the process that we go through from research to experiment. But all of that stuff happened, I would say, over the course of four sprints or so maybe 8 weeks total. And then a lot of it was just sitting back and seeing how people respond. So like I said, a survey can change behavior. There's this concept of the nudge effect, super cool case study that they did, I think in England, on people that pay taxes. That was sort of another contributing factor to why we wanted to do a survey instead of another option, was we wanted to nudge people in the right direction and proper behavior, let's say, or at least consideration as part of that survey, because we knew we weren't going to be taking action until later. So a survey actually nudged people in the right direction initially, which was an awesome thing to see. We did a calculation, a value calculation. I can't tell you exactly how much revenue we saved, but it's definitely in the millions. So $1 million plus there. So we can quantify. We look back at our Jira data and we said, now we're resolving these bugs faster. We know that there is a dollar amount associated with these bugs. And so we estimated pretty pessimistically $1 million plus revenue savings just by resolving bugs faster now. Again, shout out to Freakonomics for that. And then the last 2 points are mainly around suggestions for you. I don't know, who's attending and where you're at in terms of your maturity for how you're doing bugs and features and things like that, but have a classification matrix in our case where we say if it's leaking this amount of revenue or this amount of TPV, or we're receiving this TPV as total transaction volume, or we're getting this number of customer calls, then it's this priority of bug. Definitely you want to have that as sort of the go-to way of classifying the priority. And also look at an SLO, again, service level objective, on your bug priority. So how fast should people resolve a P1 bug versus a P2 bug? Definitely have that, and definitely try to hold people to that. With that, I will go to the acknowledgements, and then we can definitely take some questions after. So acknowledgements here, we had quite a few people on the patent, a pretty diverse group of folks. So Ifan and Hayo and John, Shri and myself on the patent. I think we did several iterations of that to get to patentability, because I think we believed this was a very unique solution. I'm sure, like I said, you could take the same idea, apply this to something else, and probably really reach patentability in that way as well. We also reached out to experts to label data, like I said. So in this case, Shiva and Josh and Utkarsh and Nilesh really helped, like I said, use our internal tool that we wrote to label that data, to make sure that we had good labels to say, this thing is a bug, this thing is a feature. So thanks to them as well. And then thanks to you all joining from your homes in the current situation. Thank you for attending. Thanks to Prepare.ai and Cindy for accepting my talk. And finally, this is actually based on a Medium blog post. So if you go to tiny.cc, prepare bugs, it'll take you to the Medium blog post, has a ton more text, some more images, more pictures, things like that. And then if you want to connect with me, I'm proof by concept on all the major platforms, and then obviously on LinkedIn. And with that, I think we can go to questions with about 20 minutes left or so.
All right, thanks, Greg. So for all of you viewers out there, I'm Bree. I'll be asking Greg any of the questions that come through in the Q&A. Please just go ahead and check out your Whova app and submit them in the Q&A section of the site. While we're waiting on additional questions, I have one for you, Greg. So I want to go back to the survey that you did in the results, and I'd love for you to interpret those a little bit for us. So it seems like the people that received the survey but didn't respond changed their behavior more. The people that got the survey and did respond changed their behavior less. Why do you think that is?
Yeah, I would love to be like a psychologist at this point. I think there's a couple of things here. And also there's another key point that I didn't really talk about. It's still equally as valid. And that is there's sort of a halo effect that we noticed. People receiving the survey would potentially talk, this was like when we were in the office, right? So people would talk to their neighbors and say, hey, I got this survey. I'm being asked to tell this team why this thing was moved, right? And we saw some of the network effect of people receiving a survey, kind of Big Brother is watching. But I think just receiving the email or just receiving that Slack, just knowing that you're being watched, I guess, is my mind, like the police effect where somebody's following you and you're like, okay, I need to be on my best behavior. I think that's sort of what happened here. And the people that submitted the survey was 120 or so people. I would have loved to have a larger sample size there. It's actually good that we didn't, I guess. But yeah, I would say just the simple fact of, oh, wow, I didn't know that anyone was doing this is probably why it changed the behavior. And again, sample size on the people who actually received the survey, but maybe didn't fill it out is a larger sample size. I want to say it's like 2 to 3x the size of the people who actually answered the survey.
And just to confirm, so the way their behavior changed is that they were misclassifying at a better rate thereafter.
Yeah, basically zero at that point. And the misclassification again is based on the model that we had. So the model that we had is only so accurate by itself, right? 0.91 F1 score. And then there's some margin of error there too. But yeah, I mean, exactly. So our model, we could run it whenever we wanted. It took a few seconds to get that feedback. So we were tracking them. They didn't really know we were tracking them on how accurate they were being at the misclassification part. Yeah.
I kind of wonder if the people that responded to the survey felt like they had a better defense for the misclassification in the first place, in which case their behavior wouldn't change as much.
Yeah. I mean, there were some options there. That's a good point. There were some options on the survey where it's basically like, yeah, this thing isn't actually a bug, so I'm doing the right thing. Yeah, definitely true. The interesting one, so one example we found is there's a team that's sort of involved in reports and reporting. And a lot of the things we were finding as bugs there were being moved to features or improvements. And there's almost a way they needed to automate that process, or at least make that feature better, right? That we were giving to customers. There was some manual work being done to sort of help that, carry that feature along to make it good, but we were still getting these bugs coming into the system. And what they realized is they needed this is tech debt. So they needed to invest time to improve that feature so that customers would just get a better experience. So this is kind of going back to the BMW knob that I talked about, where it's like, it works, but could it work better? And could be better for people to use? And that's what we found as well.
Gotcha, that's interesting. Well, I'll ask you one more question. So you talked about prioritizing. Do you have any best practices besides what you've mentioned so far about prioritizing according to customer contracts, or how you track what you need to do for each different type of customer?
Sure. Yeah, what I could tell you there is, I can't even remember how many years ago this was, but when we first did our priority classification matrix, we call it, it was actually part of a rotational leadership program that we have at the company, where for 6 months, this was somebody's sole duty, was to actually make this product, the classification matrix, to figure out what the right priority should be. And the way that we did that was, we definitely look back at old data. We have sort of a site reliability team that handles live bugs, and got their feedback, talked to our call center, folks in the call center, to get their feedback. And this took a while, right? I want to say months, to actually originally come up with what is priority 0, what is priority 1. Big part of it is how much money, like I said, how much money we're losing. That'll change the priority one way or the other. But if you look in terms of operational costs, that's a big driver of a lot of this. So calls to our call center definitely is a driver in operational cost. People filling out support tickets and things like that, operational cost. So if you get a good idea of your overall operational costs, it's pretty easy, I guess, to then apply either percentages or some breakdown to figure out, okay, this is our P0, this is our P1 priority, this is our P2 priority, and so forth. Like I said, it took months for somebody to come up with this years ago, and I think it's definitely paid dividends for sure.
All right, great. Unless we have any more questions, we can go ahead and wrap up. Thank you so much for your time today, Greg. This was super interesting. And then for everybody else out there, I just want to send a quick couple of reminders. There's something very fun happening from 3:45 to 4:15. It's you can learn how to go from 0 to hero in TikTok. And then at 4:15, please join us for our keynote speaker, Marlon West from Disney, who's talking about how AI is revolutionizing animation. Very, very great stuff coming up. And the Marlon West session will not be recorded. So make sure you join us at 4:15. Thanks, Greg.
Awesome. Thank you, Bree. Thanks, everybody.